If we want to live in a greener future, we need our buildings to be sustainable and efficient. But a building is many things and has many uses. So when we investigate how to make this happen, having so many options becomes a big challenge. Luckily, energy efficiency is a well-studied field. Knowing a building's properties, like its size or materials, we can create a model to predict its energy consumption. We also know that the energy we use in a building is affected by variables that change over time. If we know these variables, we can predict how the consumption will evolve. In real buildings, these variables that change in time often describe events that may or may not happen, like the weather conditions. They change over time, our predictions are never 100% accurate, and they definitely affect what you do at home. So sometimes our buildings consume this or this and other times this. Our goal is to incorporate this uncertainty to our existing buildings models by using stochastic differential equations, a modeling framework that enhances our prior physics knowledge with statistics. In this framework, we depart from a model that describes the energy usage in a building based on what we know will certainly happen. But we want to take into account uncertain events as well. So, how do we add something to the model we do not even know it is going to happen? We add a random variable that can take all values. This alone leaves a messy picture. In order to limit this randomness, we use measurements of real buildings. Our random variable will account for the measurements that are not what we expected. So we are able to carve out the randomness and see patterns where there was only noise. Since we understand the physics of our system, we can interpret these patterns and discover phenomena that affect the energy usage that we ignored before. This kind of detail gives us a deeper understanding of how we use our energy, which hopefully will help us to better use our resources to define our future homes.